Everyone. We are going to start our new unit today, and we are going to be taking a look at trigonometry. Now, before we can get to trigonometry, we want to review how to solve some equations so that we can be able to rearrange our trig functions and trig ratios. So, looking at solving linear equations to start with. Solving algebraically means that we are going to isolate our variable, and that means that we need to start moving some things around and getting rid of things from side to side. We know that that means that we're doing the opposite operation on the other side. So when we're solving algebraically, in our first example here, we want to isolate our x, so we're going to take our 7 over to the other side. It was adding on the left, adding on the left means that we're going to subtract on the right. So x has to be equal to -10. And we can always check that in our original expression. -10 plus 7 does give us -3. We know that that's true. Now, for part B, we know that we're going to divide on the other side. We're multiplying x with -4. Moving -4 to the other side means we're going to divide. So x is equal to -3. Again, checking our solution, -4 times -3 does give us 12. For part C, we've got a couple of steps we've got to do here. First thing is we get rid of anything that is not directly attached to our variable. So we can move our 3 over first of all. When we do that, it becomes a plus on the opposite side, leaving us with 15. Then we're going to take our 5 to the other side, was multiplying on the left, which means it becomes dividing on the right, which means that x is equal to -3. Again, double checking, 5 times -3 is -15, take away 3 does give us our -18. Our equation is true. For part D, now we notice that we have more than one x term. Well, we need to put any like terms together. So we're going to move all of our variable terms to one side, all of our number terms to the other. So we had -3x here. We're going to take our 4x over with that, where it becomes subtract on the opposite side. We had 10 over here. We're going to bring our 4 over and simplify. So we get -7x equals 14. Then we're going to divide 14 by -7. Notice the sign doesn't change. The operation changes. And again, we can always check it by subbing into the original expression. For part E, in order to get rid of the 7, x was divided by 7, which means we're going to multiply by 7 on the opposite side. So x has to be equal to 14. Now, we could have also taken the denominator that we needed to get rid of and multiply both sides by that. Again, multiplying by 7, dividing by 7 gets rid of our 7 on the left. We're left with x equals 14. Part F, when we have x on the bottom, we cannot solve for something that is in the bottom of a fraction. So we're going to start by cross multiplying. And that just means that we are getting rid of our denominators. So we're going to have 9.4x is equal to 30 times 6.5. And simplifying, we know that 9.4x is equal to 195. Now we're going to divide 195 by 9.4, which means that x has to be equal to 20.7. Part G, 1/5 y equals 2. Again, we have a couple of different options here. We can multiply both sides by 5. So if we do that, we know that 5/5 simplifies to 1, so y is equal to 10. We also know that 1/5 y is the same as y over 5. Because multiplying, we multiply our numerators, multiply our denominators. Y is the numerator of a y over 1 fraction. So again, that just simply means if we're going to move our 5 to the other side, we still get y equals 10. For part H, we have to simplify this. We want to get rid of all of our brackets first, and we want to collect our like terms. So our first step, 6x. Now notice that our minus here means we're minusing both of our terms here. So we're going to have minus 4 times x, or 4x, minus 4 times 3, or 12. Again, over here, minus means the signs of both of those things inside the brackets must change. And now we have nothing attached to anything else. We can start moving things around, putting all of our x terms on one side, number terms on the other side. So bringing our 2x over becomes subtract, 3x becomes plus, 1 and 17 were already over here, and we're going to bring our 12 over where it becomes plus. Simplifying, we get 6 minus 4 is 2, minus 2 is 0, plus 3 means we have 3x, and equal to 30 means that we're going to divide both sides by 3, or 30 divided by 3 means x has to be equal to 10. Now, as I mentioned, we can check our solutions, and when we do this, we're doing our two sides separately because we want to prove that both sides are equal. We don't know that until we sub into our original expression. So on our left-hand side, we're going to have 6 times x, which we are pretty sure is 10, minus 4 times 10 plus 3. Simplifying, we can multiply our two numbers out front is 60. Inside our brackets, remember BEDMAS tells us we must do our brackets first. So we're going to have 60 minus 52, which means we get 8 on our left-hand side. On our right-hand side, we're going to have 2 times 10 minus 3 times 10 minus 1 plus 17. Simplifying, 20 in our brackets, multiplication first, 30 minus 1 means we're going to minus 29, and plus 17, which also gives us 8. So we know that that's true. So since, and we always want to do this part to prove why we did this and what it means. So since the left side equals the right side, we know for sure x equals 10. That is our solution. So you have some questions to practice this. Note that our first textbook is no longer applicable. We talked about it midterm. We were going to switch over. So your worksheets for the upcoming units are all going to be attached to each day's lesson. So under work assignment, you'll have a PDF that you can click on to get the questions that are assigned to you for that day. Okay? And as always, don't forget